Hello friends, welcome to Risingpearl.com. Today we are talking about series 2 where we are learning about triangles. This is webisode number 18 and friends, today's topic is solving problems based on similar triangles. This is our part 2. In webisode 17 friends, we started looking at these questions or problems based on similar triangles. So this is webisode 18 part 2. Let's dive right in. So the first question that we are going to take a look at, friends, is something like this. In triangle ABC, DE is parallel to BC. DE is a straight line such that DE is parallel to BC. So it has been given to us that this is parallel to BC. Now prove that triangle ADE and ABC are similar. So friends, we can visualize this in this fashion. So we can look at the triangle ABC and ADE as there are two triangles. I have a big triangle ABC and I have a small triangle ADE. Now in real life, when you're solving these questions on your papers, you are not going to draw two separate triangles like this. I am drawing it in this fashion just to help you visualize that there are actually two triangles. There is a smaller triangle and then there is a larger triangle, and I'm going to use this tape throughout this and the next few webisodes, friends, to break out the different triangles which are not hidden but they are basically masked under one large triangle. So let's find out how can we actually prove that these two triangles are similar. So my favorite way to prove two triangles are similar, if I can, is using the angle-angle similarity rule. Why? Because this is the least amount of work. So all I have to do is I have to show two angles in one triangle are equal to their corresponding two angles in the other triangle, and then we can say two triangles are similar. Now let's take a look. So because DE is parallel to BC and AB is a transversal, so we can say these two angles are equal, right? In other words, because DE is parallel to BC, right? And AB is a transversal. AB is a transversal then we can say angle D is equal to angle B. When I say angle D, I am referring to angle ADE and angle B as angle ABC. Why? Because corresponding angles are equal. This is a theorem we have learnt in our earlier classes, that corresponding angles are always equal, right? Similarly, angle E will be equal to angle C. Angle E is equal to angle C. So friends, now if I take a look at triangle ADE, the small triangle, and the big triangle ABC, so if it were like this, what we have is this angle equal to this angle and this angle is equal to this angle, right? If we know this, then we can say these two triangles are similar. So we can say yes, indeed, triangle ADE is similar to triangle ABC by our favorite similarity rule, which is AA similarity rule, that is angle-angle similarity rule. Friends, let's take a look at our next question. So here in our next question we have triangle ABC, again DE parallel to BC. We have been given DE parallel to BC. Prove that, we have to prove this ratio. Let's take a close look at the ratio. So the ratio is telling us AD by AB is equal to AE by AC. If you recall friends, this is nothing but the equiangular ratio, right? So let's take a look. So what we can say is that because these are parallel, right? So if you take that, if you take triangle ABC, you have DE which is parallel to BC. So what can we say? If, okay, let's write the triangle. In triangle ABC, we have triangle ABC. In triangle ABC, we are given that DE is parallel to BC. This is given. So we can say from basic proportionality theorem that AD divided by DB must be equal to AE divided by CE from basic proportionality theorem, right? If you have parallel line, so that line intersects the other two sides of the triangle in same ratio. Now let us say, so if these ratios are correct, this implies their reciprocal will be also equal. So DB by AD must be equal to CE by AE. Right? Now we want to add the number 1 on both sides. So we have, let's write it here. So we have DB by AD plus 1 is equal to CE by AE plus 1. Now friends, we have solved these questions before, so you will take the LCM on this side. LCM is AD, so you will have DB plus 1 times AD is AD. Similarly, on the right hand side of the equation, LCM is AE, and you have CE plus AE. So this gives us, let's continue on from here, we come here. So DB by DV plus AD. DB plus AD is nothing but AB. So we will have AB in the numerator divided by AD equal to CE plus AE. CE plus AE is nothing but AC. AC divided by AE. If we take the reciprocal of this, we will get AD divided by AB is equal to AE divided by AC. So friends, we started out with what was given to us, and we have proved that this ratio is indeed correct, and this is what we had to prove. AD by AB is equal to AE by AC, AE by AC. So friends, this is second type of question that you may be seeing. Now this question friends here, question number 3, is really very similar to what we just proved. So I will actually leave this up to you for you to go ahead and give it a go. Let's look at question number 4. Now here friends, there are actually, this question 4 has 4 parts. So what is given to us is, in the figure here, the altitudes PS and QT of triangle PQR intersect at Q. So first of all, we are given a triangle PQR. There is one big triangle PQR, and the altitude PS and QT. So from P you drop a perpendicular intersecting QR at S. So this angle is 90 degrees, right? So this is 90 degrees. and from Q we drop a perpendicular QT on PR, so this angle is 90 degrees. This is what is given to us, and these two intersect at X, so this point is X. So we have to prove these triangles are similar. So let's take a look at one by one. So the first one is X SQ. X SQ, this triangle, and XTP, XTP, this triangle. So basically first we have to prove this triangle and this triangle are similar. Let's take a look how we can actually do this. So here friends, I have broken this down. So again, in your real solution you are not going to be breaking it down like this, but I am doing that so that you can clearly visualize. So we are talking about two triangles. So we have XSQ, and this angle is 90 degrees, and XTP, this angle is 90 degrees, right? We have to prove that these two triangles are similar. So what do we know? So we know that in these two triangles, QXS, that is this angle, must be equal to this angle. Why? That is, these two angles, this angle and this angle, are actually equal. Why? Because they are vertically opposite angle, right? Then we talked about how this angle and this angle are 90 degrees. So we can say that both this and these two triangles are similar by our very special AA similarity rule. Remember, we just have to show two corresponding angles are equal. So two sets of corresponding angles are equal. Then we can say the two triangles are similar by AA similarity rule. Now let's take a look at our part 2, which is QRT. So we have to show QRT, this triangle QRT, this triangle is similar to PRS. So this is that's why friends, I am actually breaking down the triangles so that you can understand it, because if you look at it sometimes it can get a little bit harder to visualize, but you really need to pay attention and focus on these kind of questions. So QRT is this triangle QRT, that is QRT, and PRS or PRS, this triangle. So in these two triangles, friends, what do we know? So one thing is that this angle is 90 degrees, right? So QTR, this is angle T, and angle PSR, this is 90 degrees. So these two angles are equal. Also, if you note, friends, in both of these cases, this angle is common. That means this angle is equal to this angle, and this angle is equal to this angle. That means both triangles are similar. So we can basically say in these two triangles, angle R is same, right? QRT is equal to PRS, same angle, and QTR is equal to PSR, both 90 degrees. So again, from AA similarity rule, we can say that these two triangles are indeed similar triangles. So friends, now let's take a look at the fourth part, or the third part, which is the triangle QSX. QSX. This triangle is similar to QTR, which is QTR. So the smaller triangle QXS is similar to triangle QTR. So the way to look at this question, friends, is that again we are going to be doing the same thing that we have been doing. Angle Q, in both the cases, this angle is the same, and this angle is 90 degrees. So we have one same angle and one 90 degrees. So both triangles are again similar by a similarity rule. So friends, as you can see, if we can, our go-to method will be to prove two triangles are similar using a similarity rule, because it is the least amount of work for us. But we have to pay extremely careful attention to which triangles we are looking at and which are the corresponding angles that we are looking, if they are equal or not. So similarly friends, we have one more part to go. I will leave that up to you. Now let's take a look at the next question, question 5. In this question friends, what we have is, in the figure below, S is a point on the side FE produced of an isosceles triangle DEF with DE equal to DF. So we have an isosceles triangle DEF with DE equal to EF. This is given. Now S is a point on side FE. So you extend FE all the way to a certain point S such that DE, this length DE, actually no. S is a point produced of an isosceles triangle with, okay, so how far do we have to go? So if DP is perpendicular to EF, so the other thing which is given is DP is perpendicular to EF and ST is perpendicular to DF. Okay, so this point you will go to such a distance whereby when you drop a perpendicular from S, this ST is perpendicular to DF. So S is such a point. So again, just quickly recap. So we have isosceles triangle DEF. DE is equal to DF. Isosceles triangles, two sides are equal. Then we extend FE to such a point S such that ST is perpendicular to DF. Also we drop a perpendicular DP on EF. So this is what we have been given, and we have to actually prove that these two triangles, again we have to be very careful when we look at which two triangles, DEP, that is this triangle DEP, is similar to SFT, this triangle. That is this triangle is similar to this triangle. So here friends, we have just taken out the two triangles DEP and STF. So we have to show that these two triangles are actually equal. So now if you take a look at these two triangles, so the first thing you will notice is that DEF is a isosceles triangle. So this angle is equal to this angle, right? So angles opposite to equal sides are equal in any triangle. So if you draw any triangle, if this side is equal to this side, then this angle should be equal to this angle. So because DE and DF are equal, these two angles are equal, right? So now if you look at, so what you have is, so this angle is here and this angle is this angle. So if you look at now these two triangles, this is 90 degrees, this is 90 degrees, and these two are equal. So we can say yes, this triangle and this triangle are similar by a similarity rule. Friends, again, I am not going into writing it in great amount of details. So on purpose, I'm just trying to help you focus as to understand how we have to approach these questions. Let's take a look at maybe one more example before we wrap up this particular presentation. So S is a point on side QR of a triangle PQR such that PSR equals PQR. Show that PR square equals RQ times RS. So friends, this is an interesting question. First of all, there is no diagram which is given. So we have to draw the diagram ourselves. So how do we do it? We first draw a triangle PQR. Because we have a triangle PQR, so we start out by drawing a triangle PQR. S is a point on QR, so this is my QR. S is some point on this side QR such that PSR, so if you join PSR, this angle is equal to QPR. So these two angles are equal. That is what is given, right? And now we have to prove this ratio. So how do we start? So in triangle PSR and PQR, so if you look at triangle PSR and PQR, what do we know? So I'm taking the two triangles, right, where we have a relationship. So I'm taking this triangle where one angle is given. So PSR and PQR, right? So what is given, friends, is that angle S, this is equal to angle P. This is given. This is my first condition. And this angle is actually same in both the triangles. So I can say that these two triangles are similar triangles by AA similarity rule. Now after I have established they are similar triangles, so we can actually write the ratios. Remember that corresponding sides have the same ratio, or they are proportional. So this is very important, friends, for you to know which side is corresponding to which angle, right? So first we will write the small triangle or the triangle PSR. So we have this angle, right, angle S. So opposite to angle S is PR. So we write PR divided by, in the big triangle opposite to this is QR. We have this. Opposite to angle R in the small triangle is PS. So PS. Opposite to angle R in the big triangle is PQ. So PS by PQ equal to PR by QR equal to the other two remaining sides from each triangle, right? So now that we have this ratio, if you look at the question, I need to find 2 PR, right? So if I take these two ratios, I have 2 PR and I have RQ and RS. So PR by QR is equal to RS by PR. Then simply, if you were to just bring the PR in the numerator, so essentially what you have is you have PR by QR equal to RS by PR. So instead of leaving the question as a ratio in the ratio form, here they have gone ahead with one extra last step. They have taken this PR here and they have taken this QR here. So if you do that, what you will have is PR times PR will be PR square, right? Which will be RQ, it will go up there, RQ multiply by RS. So hence, friends, we have actually proved the question using similar triangles. In the next webisode, we are going to take a look at some more questions on similar triangles.